Good morning, students. Hope you all are doing good. Welcome to today's physics session. Children, today's topic which we are going to discuss doesn't need any introduction. That is electric current. It plays a significant role in our day-to-day life. It is just like a lifeline of every household. Without electricity, we can't manage. It is quite difficult, right? Let us compare the life before electricity and after electricity. Before electricity, it is very difficult for the children to study in the dim light of oil and kerosene lamps. And it is very difficult for the woman to cook the food after sunset. If a person wants to communicate, he has to depend on letters and telegrams, etc. And after a few days, he used to get a reply. Now, children, let us see life after electricity. Now, happily, students are studying during the night time. Just they need to press a switch of electric light. Now, cooking also is not a big deal after the invention of electric bulb. Using mobile phones and internet, we are able to communicate within seconds. What we understand is electricity has brought a drastic change not only in our lifestyle but also in agriculture sector, industrial sector, medical field and so on. Electricity plays an important role in the development of country too. Now, children, before we discuss about the topic, let us see what are the objectives of this session. At the end of the session, you will be able to define electric current, state Ohm's law, write the uses of electroplating, and explain about electric shock and its effects on human body. Now, these are the objectives of this session. Let us discuss what is electric current. Look at this picture, children, in this slide. When same type of particles move in same direction, they form current. Now, in one of the picture we see flow of water particles in a river form water current, and flow of air particles from one place to another place form air current. Similarly, when electric charges flow in one direction, they cause electric current. Children, we have already discussed in the previous session how these charges are carried by charge carriers, electrons. Metals are good conductors. They contain free electrons. What do you mean by free electrons? Let us discuss about it. Electrons present in the outermost shell. Electrons present in the outermost shell are known as free electrons. They are free to move because they are loosely bound to the nucleus. Now, these electrons, when they flow in one direction in unit time, it is known as electric current, We can define the electric current in another way, as the orderly motion of electrons is also called electric current. Let us see the formula. The rate of charge of electric current is known as the rate of flow of charge is known as electric current. Here Q is charge and T is time. Now, electric current is measured by a device called ammeter. You can see its picture in the slide. Now, the unit of electric current is ampere, named after a scientist, Andre Marie Ampere. Now, this is about the electric current. Children, here the question is, what makes those charges to move in a conductor from one point to another point? What exerts a force on the charge? Let us discuss with a simple example. Now you are given a bulb and a wire. Connect both free ends of the wire to the bulb. Does the bulb close? No, because there is something missing in this circuit. Can you guess what is it? Yes, it is battery. As soon as we connect a battery in the circuit, the bulb starts glowing. Let us discuss how battery works in a circuit. Children, electrons in the copper wire do not move on their own, just like water present in a perfectly horizontal pipe. If one end of the pipe or tube is connected to a water tank, if one end of the tube is connected to water tank, the water starts flowing through the pipe. Here, when one end of the tube is connected to the water tank, a pressure difference is created across the ends of the tube and the water started flowing through it. Let us see with another example. Children, I have a cardboard cylindrical tube and place a marble inside it. Place a marble inside it. Now, when I hold the pipe horizontal perfectly, the marble does not move from its place. It remains in the same place. Now, what should I do to make that marble move? Simple. If I raise one end of the tube, it makes the marble to roll easily. I think you have understood how the battery is going to work when it is connected in the electric circuit. Exactly. When battery is connected in the circuit, it creates a potential difference. One end is at higher potential, another end is at lower potential. By creating this potential difference across the wire, it exerts force on the charge and charges start flowing through the wire. Let us define electric potential. Electric potential the amount of work done to move a charge from one point to another point. Electric potential is defined as amount of work done to move the charge from one point to another point. The unit of electric potential is volt. It is named after Alessandro Volta, a famous Italian physicist who prepared a cell which can convert chemical energy into electrical energy. As it measures potential difference across the conductor, it must be always connected in parallel. Now let us move to the next topic. Children, before we discuss about the topic, let us look at this picture. Here, a girl is riding bicycle. While riding a bicycle, it is very easy to move forward if we are moving in the direction of wind. Imagine what happens when we move in the opposite direction of the wind. It is very difficult to move in the opposite direction of the wind because air exerts pressure in the opposite direction. It offers resistance. Similarly, ions present in the metal oppose the movement of free electrons by colliding with them. Now in the slide you can see how the collisions are taking place between the ions and the electrons. Children, in the second picture you can see voltage is pushing the electron to move forward, whereas resistance is opposing it. So we can define electric resistance as obstruction offered to the flow of electrons is known as resistance. Resistance is measured in ohm. It is denoted by the symbol omega. Now we use a device, ohmmeter, to measure the resistance in a circuit. Resistance phenomena was discovered by George Simon Ohm in the year 1827. Now children, let us see what are the factors affecting the resistance. Factors affecting the resistance. What will happen if filament of the bulb is made up of copper? Does the bulb emit light? No, because copper has low resistance. Electrons move freely in the copper and the copper wire does not turn into red hot on passing electricity and it will not emit light. Whereas if we make the filament with a tungsten wire which has high resistance, on passing electricity the filament turns into red hot and emit light and heat energy. So what we understand from this example is resistance varies from material to material. we can say that resistance depends on nature of material. Now let us see what are the other factors. Children, it is very difficult to push the water through a long narrow tube than a wide short tube. Similarly, electrons move freely in the wide short tube than long narrow tube. So we can say that resistance increases with the length of the wire and decreases with area of cross section. Electrons move freely in wide thick wire, whereas they do not move freely in long narrow thin wire. We can write these factors in the form of equations. Resistance is directly proportional to the length. When the length of the wire increases, resistance also increases. Resistance is inversely proportional to area of cross section. When the area of cross section increases, resistance in the circuit decreases. Children, this together is known as laws of resistance. Now, other than these three, do we have any other factor upon which the resistance depends? Yes. When we increase the temperature of the wire, electrons pick up that heat energy and start moving more vigorously. Due to this, more number of electrons collide with ions. As a result, resistance in the conductor increases. So we can say that when temperature increases, resistance also increases. So children, we have studied about the factors which affect the resistance. Number 1, it depends upon nature of material. For example, nichrome, tungsten, steel has high resistance. We cannot use them for the power transmission because they get heated up immediately on passing electric current. Now the second factor is when the length of the wire increases, resistance also increases. This is the reason why the filament of the bulb is made very thin and long. Resistance decreases when the area of cross section, thickness of the wire increases. And the fourth factor is temperature. When the temperature increases, resistance also increases. So these are the factors which affect the resistance. Children, is there any relation between the potential difference across the conductor and the current passing through it? Let us discuss with a simple example. Now, here we have two beakers. Connected with a pipe. Both the beakers contain same amount of water. Does the water flow? No. What happens if one of the beakers is placed at certain height? When it is placed at certain height, the water starts flowing from beaker B to A. Here the water level increases. It means the height difference made the water to flow from this beaker to this beaker. What will happen if we increase the height little more? The flow of water will increase. Water will start flowing with great speed if we increase the height of the another beaker. So from this we can say that height difference is directly proportional to the flow of water. Children, let us see another situation. What happens if we make this pipe more thinner? What happens if we make the pipe more thinner? The flow of water becomes slower when we make the pipe thinner. It means thinner the pipe, flow of water decreases. Can we compare this with the Ohm's law? Let us see. Assume height difference as potential difference. When the height difference is increasing, the flow of water also increasing. Flow of water as flow of current, and the thinness of the pipe as resistance. Children, from this example we can say that when the potential difference across the conductor increases, the flow of current also increases. It means V is directly proportional to I. Here V is a potential difference and I is a current. So we can state Ohm's law as, you can see in the slide, at constant temperature, potential difference across the conductor is directly proportional to electric current passing through it. You can see, children, in the slide, there potential difference is pushing the electron, whereas resistance is opposing that movement of electron in the conductor. Children, let us discuss an experiment to verify this Ohm's law. What are the materials required for this experiment? We need an ammeter, a voltmeter, iron spoke, a plug key, and 5 dry cells of 1.5 volts each. Connect the circuit as shown in the figure. Voltmeter is connected always in parallel and ammeter is connected in series. Connect the circuit as shown in the figure. Now, connect first one dry cell in the circuit and close the plug key. Here iron spoke. Children, connect one cell in the circuit and close the plug key. Current starts flowing through it. Note down the current reading from ammeter and voltage reading from voltmeter, and note the readings in the table as I1, V1. Now, in the second case, add one more cell, close the plug key, and note down the readings of current from ammeter and voltage from the voltmeter. Note that readings in the table I2 and V2. Now repeat the experiment with 3 cells, 4 cells and 5 cells, and every time note down the readings from the ammeter and voltmeter respectively. Find V by I ratio for all the cells. For each case, find out the V by I ratio. What we find is the values in the last column are almost same. We understand that V by I is constant. Bring this I here. Constant. Remove the constant, we will get a proportionality. V is directly proportional to I. Hence, Ohm's law is verified. The potential difference across a conductor is directly proportional to the current passing through it. Now, draw the graph taking these values take voltage on x axis and current on y axis. When you draw the graph, you will get a straight line. Now children, repeat this experiment using an LED instead of iron spoke. Note the readings for each case and draw the graph taking those values V on x axis and current I on y axis. We will get a curved graph. Children, you can see in the slide, for iron spoke the graph was straight line graph, and for LED the graph was curved graph. So based on Ohm's law, materials are classified into 2 categories. The materials which obey Ohm's law are known as ohmic materials. The materials which obey Ohm's law are known as ohmic materials, whereas the materials which do not obey Ohm's law are known as non-ohmic materials. So based on Ohm's law, they are classified into 2 types: ohmic materials and non-ohmic materials. Children, now let us discuss about the different effects of electric current. Before we discuss about the effect, look at this picture in the slide. What do you see in the picture? A woman is ironing the clothes. Children, whenever we get ready to attend a function, a party or meeting, we see that our clothes are not crimped. For this, we use an electric iron to straighten out the clothes. Now, electric iron is not only one device, there are many such devices which become hot on passing electricity. Children, you can see in the slide electric iron, bulb, fuse, electric heater, electric toaster, stove. These are the devices which produce heat energy on passing electric current. Children, before we discuss the mechanism of these devices, let us look at this word iron. You might have heard this word in chemistry. It is a name of the element which is denoted by the symbol Fe. And iron also an important mineral present in the protein called hemoglobin, and shortage of iron causes anemia. This is about the word iron. Now let us come back to electric iron. Children, how electric iron becomes hot on passing electricity? We all know that conductors contain free electrons and they move freely in metals. While moving, these electrons may collide with the ions present in the metal. During collision, a part of energy is getting converted into heat energy. As we all know, the law of conservation of energy. Energy is neither created nor destroyed. It can be changed from one form to another form. So during collision, a part of the energy is getting converted into heat energy. These all heating devices contain nichrome wire which has high resistivity. Children, the filament of the bulb, as we have discussed earlier, it is made up of a metal called tungsten which has high resistance. As soon as the current passes through the wire, it turns into red hot and emits heat and light energy. So, these are the applications of heating effect of electric current. Children, other than this, there is one more device which works on heating effect of electric current. In our house, we draw, for household usage, we draw the current of 0 to 20 amperes from the mains. When current exceeds a limit, it may cause damage to electric appliances. So to protect from that damage, we use a safety device called electric fuse. Electric fuse has a metal wire which has low melting point. When current passes through this wire, it melts and the circuit is broken. Current stops flowing through the household appliances. In this way, we can protect the household appliances during overloading by using a safety device called electric fuse. So this also works based on heating effect of electric current. Now children, this is about heating effect of electric current. Let us discuss about another effect. Before that, look at this picture in the slide. In the first picture, fireman is spraying water. Children, whenever a fire accident take place, firemen reach there and before they spray water, they make sure that the mains are off. Why do they do so? It is because without switching off the mains, if they start spraying water, the current will pass through the water and it may cause harm to the firemen. So they make sure that the mains are off before they start spraying water. Now coming to the next picture, why are we advised not to touch the electric poles during rainy seasons? During rainy season, the electric pole is wet. Current may pass through it and it may cause harm to the person who is touching it. So, what we understand from these two pictures? We understand that not only metals, liquids also conduct electricity. Children, let us perform a small activity to test whether liquids conduct electricity or not. Now, here I have taken a liquid into a small plastic cap. Children, here the circuit consists of a battery, a switch, LED and the wires. Here, when the two ends of the wire are placed in the liquid, let us see the bulb glows or not. We see the bulb is glowing. It means the solution which is taken in this plastic cap is conducting electricity. Children, liquids also conduct electricity. Acids, bases, salt solutions are good liquid conductors as they contain ions in them, and these ions carry the charges from one point to another point. Suppose if we replace the solution with distilled water and check whether the LED glows or not, we will see that LED does not glow because the distilled water does not conduct electricity. There are no ions in it. Now, can we make distilled water to conduct electricity? Yes, by adding a pinch of salt or few drops of acid or bases, we can make the distilled water to conduct electricity. Children, the solution which is passing the electricity is known as electrolyte. The solution through which the electricity is passed is known as electrolyte. Acids, bases and salt solutions are examples of electrolytes. Now, repeat this activity with different liquids and test whether the LED is glowing or not. If the LED is glowing, they are good conductor of electricity. They are the examples of electrolytes. If the LED is not glowing, it means they are not allowing the current to pass through itself. For example, oil, distilled water, is example of, they are examples of non-electrolytes. lights. Children, when the current passes through a solution, it causes a chemical reaction, and it is known as chemical effect of electric current. Now, let us see another effect of electric current. Before that, let us see what are the applications of electric current. Children, electroplating is one of the important use of chemical effect of electric current. Jewelry made of low cost metal like aluminium and iron are coated with silver and gold. Not only that, automobile parts are coated with a non-corrosive metal, chromium. The iron which is used in the construction of bridges and multi-storied buildings are coated with zinc. A fine layer of metal is coated on another metal by passing electricity into the solution is known as electroplating. Now, these are some of the applications of chemical effect of electric current. Children, let us move to the next topic, magnetic effect of electric current. Hans Christian Ørsted demonstrated magnetic effect of electric current. He proved with a small activity that electricity and magnetism are interconnected. When a current, he stated that a current carrying wire produces magnetic field around it. Here you can see in the slide, to perform this experiment we need 2 wires, 1 battery and a compass needle. Complete the circuit with the battery and the wire and place a compass needle below the current carrying wire. We see when the current is passing through the wire, the needle is deflecting. It means the current carrying wire is producing magnetic field lines around it, which are responsible for the deflection of needle in the magnetic compass. This is about the Ørsted experiment. Children, electromagnets are the magnets which produce magnetic field on passing electricity, and electromagnets we use in our day-to-day life in electric bell, motor, generators, MRI scans, etc. So, these are some of the applications of magnetic effects of electric current. So, totally we have discussed about 3 different types of effects: heating effect of electric current, chemical effect of electric current and magnetic effect of electric current and their applications in our day-to-day life. Here fuse, electric iron, etc. are the devices which use the heating effect of electric current. Electroplating use the chemical effect of electric current, and electromagnets used in dynamos, electric motors, MRI scans uses the magnetic effect of electric current. Now, children, let me ask you a question before I go to the next topic. What happens when you touch electric switch with a wet hands? You may receive an electric shock. What causes electric shock in human body? Is it current or voltage? Let us see. Human body resistance varies from 100 ohm to 5 lakh ohm. Suppose a person touches a battery of 24 voltage. Let us calculate the amount of current passing through his body by taking resistance as 1 lakh ohm. Using Ohm's law, Ohm's equation, we can find out the amount of current passing through his body. Here, the amount of current passing through his body is 0.0024 amperes. This current is very small. It will not affect human body. Suppose a person touches 240 voltage live wire, then the amount of current passing through his body is equal to 0.0024 amperes, and this current is quite harmful. It will affect the human body. It will start disturbing the functions of internal organs in the body, and this disturbance we call it as electric shock. If current continues flowing through the body, resistance keeps on changing and it starts damaging the tissues. Let us see here when (0.001 ampere current passes through the human body, it can be felt. When 0.0015 amperes current passes through the body, it is quite painful. And when 0.01 ampere current passes through a body, it causes muscle contraction. And when the 0.015 amperes current passes through the body, our body loses muscle control. And when 0.07 amperes of current passes through a body more than 3 seconds also, the person may lose his life. So it is very dangerous. It can be fatal. The person may lose his life. So children, here we understand from this discussion that electric shock is a combined effect of potential difference, electric current and resistance. When potential difference exists from one organ to another organ, current starts passing through it and human resistance keeps on changing and current chooses that path which offers low resistance. So from this we can say that electric shock is a combined effect of voltage, current and resistance. Children, let us see the do's and don'ts we should follow in our day-to-day life to protect us from electric shock. Here you can see in the picture the unused outlets, electric outlets must be closed, and the damaged cords of the electric devices, either they should be get it repaired or they should be replaced. And what are the don'ts? We shouldn't touch the electric devices with wet hands, and we should not operate the electric devices closer to the water. And next, the electric devices must be checked repeatedly such that all the parts of it are working properly or not. If any cable is open or the cord is defective, it may cause harm to us. Children, at the end of the session, let us recap what all we have discussed in this session. We discussed about electric current. The rate of flow of charge is known as electric current. Then we discussed about electric potential. The work done on unit charge to move from one point to another point is known as electric potential. It is measured in ampere and it is measured in volt. Now, the obstruction offered to the flow of current is resistance. It is measured in ohm, and the relation between electric current and potential difference across the conductor, that is Ohm's law. At constant temperature, potential difference across the conductor is directly proportional to the current passing through it. Then, based on Ohm's law, the materials are classified into two categories, ohmic and non-ohmic. After that, we discussed about different effects of electric current. Number 1, heating effect. Heating effect of electric current. On passing current, they become hot and emit heat energy. The second one is chemical effect of electric current. When current passes through a solution, it causes a chemical reaction and it is used in electroplating. And the third one is magnetic effect. Oersted proved that electricity and magnetism both are interconnected, and a current carrying wire produces magnetic field lines around it. So, these are the three effects we discussed: heating effect, chemical effect and magnetic effect. And finally, we discussed about electric shock. Electric shock is a combined effect of potential difference between one part to another part in the body, and the current chooses the path which offers low resistance, and the resistance of the body keeps on changing while current passes through the body. These are the topics which we have covered in this session. And finally, I just want to tell you that electricity is a great boon of modern science. We must carefully use the electricity, avoid the wastage of electricity. Without electricity, we slip back to the primitive age. As to generate electricity, we depend on natural resources. So, we must conserve electricity to conserve these resources. Children, we need to realize the importance of electricity and save electricity to protect ourselves from darkness. So, save electricity for a better tomorrow. At the end of the session, I want to thank Secretary Sir, TSAT team and GnaanaDeeksha team members and our RCO ma'am for giving me this wonderful opportunity. Thank you all.